All right, guys, welcome back. Whether you are maybe someone who was just absent, maybe you're quarantining, maybe you just want a refresher on what the content's about, this is going to be the beginning of Chapter 9, specifically Section 9.1. And what you can see on the board is three images that may or may not be familiar to you. You might be wondering, what in the world does Mr. Carter have on the board and why? Why does he have a bicycle? Why in the world does he have a tricycle? What is a unicycle doing there? Well, it seems like a nominal or a silly illustration, but I want to prove a point in doing this. All three types of these are types of cycles, I guess you could say. But what separates them is the number of wheels they have. Now, I'm guessing you probably could have looked at these and come up with the names. And when you look at each of these, the difference in each is the number of wheels. And the prefix of each goes right along with the number of wheels. A unicycle has one wheel. A bicycle has two wheels. A tricycle has three wheels. And the prefix tri meaning three, the prefix bi meaning two, and the prefix uni meaning one. Again, you're probably still scratching your head going, why are we talking about bicycles, tricycles, and unicycles and prefixes? That's an English topic. Well, you're correct. Bear with me for one more moment, though. See if you can think of a term, or a prefix that's not uni, that starts with the word M, that stands for one. If you think about it, hopefully you came up with mono. Okay? So what's the point? Well, where we're going to next is we're going to learn about kind of combining our knowledge of exponents and working with equations, and we're going to work with polynomials. Okay? And the reason I wanted to talk about bicycles, tricycles, and unicycles is because the prefixes become important. Okay, you need to know what the prefixes mean. Bicycle, we think two wheels. Okay, bi meaning two, tri meaning three, uni meaning one, but we're going to actually, instead of unit, we're going to use the word or the prefix mono. Okay, so our first definition we want to start with is a monomial. And a monomial is a single term that is some combination of a number, variable, or product of the two. Again, pause the video, go ahead and write this down. The definition of a monomial. Now, a binomial is the exact same thing as a monomial, except instead of a single term, it will have two terms. A trinomial, exact same thing, but it will have three terms. A polynomial, you might not know what the prefix poly means many, will have, well, many terms. Again, same idea. Some combination of numbers, variables, or products of the two, but what changes, depending on our prefix, is the number of terms. Okay? A monomial is the term we use, or is the word we use to refer to a single term. That is a combination of a number, variable, or product. A binomial will have two terms. Trinomial, three terms. Polynomial, many terms. Polynomial is kind of the jack of all trades. As long as there are two or more terms, we will call it a polynomial. Thus, all trinomials are polynomials, but not all polynomials are trinomials, because you could have more. Okay, Mr. Carter, we learned, and now we know the definition for these, but what do you need us to be able to do? Well, what I want you to do is I'm going to write several different algebraic expressions on the board, and I need you to classify them as monomials or binomials. Okay? So I'm going to write these algebraic expressions on the board. And once I do, I want you to classify them as monomials or binomials. Okay, well, the first things first, the question that's probably rattling around in your mind is, well, I know a monomial only has one term, and I know a binomial has two terms. But how do we tell the difference as to whether something is a term or not? Well, terms are separated by the plus or minus symbols. Terms are separated by plus or minus signs. Therefore, if we have no plus or minus signs, we just simply have a letter or a number, a variable, or a product of the two, it's a monomial. But a binomial, you're going to have a plus or minus sign present so that you have multiple terms. Okay, let's do a couple examples. Y would be a monomial. Y would be a monomial. Why? Because it is a single term. Okay, there's no plus or minuses. There are no multiple terms. You just simply have a single term, a monomial. Y plus 7 would be a binomial because there are multiple terms, specifically y and 7. You can tell that there are multiple terms because they are separated by the plus and the minus symbol, specifically the plus in this case. 3x would be a monomial because there is only one term. Now you might be sitting there going, hold on, Mr. Carter. 3 times x, that's two things. That should be a binomial. Well, look back at your definition. A monomial is a single term that is some combination of a number variable or product of the two. Okay? We can have 3 times x and it only be a monomial. What turns it into a binomial is when we have a plus or minus sign in between the 3 and the x. Pluses and minus symbols will determine how many terms there are, okay? Not the physical number of numbers or letters, but rather how many times how many times an algebraic expression has a plus or minus sign involved. So this would be a monomial because while there is a 3 and an x, the 3 and the x are multiplied together. 3x plus 4 will be a binomial. Again, we have one plus sign separating the 3x and the 4. 3x squared yz, believe it or not, is still going to only be a monomial. Again, we have a ton going on there. We have an exponent. We have 3 different variables. We have a coefficient, but none of them are separated by a plus or minus symbol. Thus, while complicated, it's only a single term. 14 minus 3x squared would be a binomial because the 14 and the 3x squared are separated by that minus sign. C divided by 3, again, a monomial because there's no plus or minus sign, just a single term. And finally, 3x minus 7x squared plus 4, well, that's actually going to be a trinomial. I threw that one in there. A trinomial because there are 3 distinct terms. The 3x is separated from the 7x squared by the minus sign, and the 7x squared is separated from the 4 by a plus sign. This would be a trinomial. Okay, so a shortcut, look at how many plus or minus symbols there are and add 1, and that will always give you the number of terms. Again, the big idea here is to know how many terms are present, we need to look at how many plus or minus symbols there are and what is being separated by the plus or minus symbols. Okay. Again, if you want a formal definition, you can go ahead and write this down. This just goes more in depth into how do we tell what does and does not make up a term. We talked about what a polynomial was in an algebraic expression with two or more terms. And now we're going to dig a little deeper into what a polynomial is. So please note, we are typically going to write polynomials. Again, polynomials being polynomials being when we have an expression with two or more terms. So a minimum of a binomial. A monomial is not a polynomial. We're going to write our polynomials with the greatest power first, followed by the next greatest, and so on. There's nothing, just go ahead and write down that definition. Nothing specifically you need to do there, but something to keep in mind. And you'll see this as I solve my problems. So what are like terms going to look like in a polynomial? Well, we've worked with problems before, like this, where you have had to simplify, you didn't know it at the time, but this algebraic expression or this polynomial. What you didn't know, you weren't working with a polynomial, but what you would have done here is you would have combined the 3x and the minus 7x to become negative 4x plus 1. To simplify this, you would have done this because the 3x and the 7x are like terms. You've known how to do this in the past. But where we're going and what you have not done yet is solving problems like this. Excuse me. You have not solved problems like we see in black. So what's the difference? Well, we still want to simplify what's in black, but it looks a little more complicated. So what do? When we have like terms in a polynomial, they need to have the same base in the same exponent to be considered like terms. We haven't dealt with this with exponents yet. So not only do we need to have the same base, but we also need to have the same exponent for them to be like terms. If two or more terms in a polynomial are like terms, we'll combine their coefficients, but we will not combine their exponents. Let me say that again. We'll combine their coefficients, not their exponents. Okay, so let's work together on simplifying the problem in black. How would we simplify this? Well, what I'm looking for is to simplify it. I'm looking to see if there are any like terms present. Are there any terms that look the same? What makes them like terms is they not only need to have the same base, but the same exponent. So let me start at the leftmost one, 4x squared. Is 6x a like term? Well, no, it's not. Why is 6x not a like term? Because 6x has the same base, but does not have the same exponent. Therefore, they are not like terms. 7, of course, does not have the same base or exponent as 4x squared. But 2x squared does. So what I'm going to do is I'm going to combine their coefficients, not their exponents. So 4 plus 2 gives me 6x squared. Notice I did not combine their exponents to become 6x to the 4th. When we are combining like terms, we do not combine the exponents. Okay, we just add the coefficients. Exponents don't change until we start multiplying things like 4x squared times 2x squared. Okay, So now let's move on to my 6x, see if I can find a like term. I notice the minus 9x, same base, same exponent, x to the first power. 6 minus 9 would be negative 3x. And then finally, I notice I have two constants. I have the 7 and I have the 1. And when I combine those together, I get positive 8. So to simplify the algebraic expression I have here, I'm going to combine the like terms, specifically the terms that have the same base and the same exponents. And when I do that, I get 6x squared minus 3x plus 8. Okay, with that in mind, let's move on. Do a couple more examples of this. 9m cubed. Let's make that 9w cubed. 9w cubed plus 8w squared plus 7w cubed plus 4. And we want to simplify this. Well, go ahead and try this on your own. Pause the video, see if you can figure this out. And then we will pick up, once you're done, check your work with mine. So to solve this, or not to solve this, to simplify this, what I'm going to do is, as what I always do, I'm going to try and identify like terms. I'm always going to start with the leftmost term and work from there. Well, I notice the 9w cubed and the 7w cubed have the same base and the same exponent. Therefore, they can combine together to be 16w cubed. Again, notice the exponent's not changing. I'm just adding the coefficients. When I look at the 8w squared, there's nothing that will combine with it. So I just bring it down. Again, we're not solving here. We're simplifying. If 8w squared can't get any simpler by combining with a like term, then we just bring it down. Same applies to my 4. I can't simplify that anymore, so I just bring it down, and I'm left with 16w cubed plus 8w squared plus 4 as my simplified version of the polynomial. All right, let's do 2 more examples, and then you will be all good for your practice. 2x cubed plus 5x squared minus 3x minus x squared minus 8x squared. Sorry, this is supposed to be x cubed plus 11. And we want to simplify this. Well, I'm betting what you're already doing at this point is you're already kind of eyeballing the like terms that are present. But let me pause you before you do that. You see, we've been able to go ahead and simplify right away because we've had a plus sign in the middle. But that's not happening here. We don't have a plus sign in the middle. We have a minus sign. Well, how's that going to change things? Well, it's different. This minus sign is different than this minus sign and this minus sign because it's sitting outside the parentheses. You see, the minus signs for the 3x and the 8x squared just apply to those. But when a minus sign, just like any other number, sits outside the parentheses, we have to distribute it, apply it to everything in the parentheses. So before we can ever simplify this, we need to make sure that we apply this minus sign to everything outside of inside of the parentheses that it's sitting out of. We don't have to do this with the first set of parentheses because there's nothing outside of it. So everything in the first parentheses will stay the same. But everything in the second set of parentheses must have the minus applied to it. So positive x cubed becomes minus x cubed. My negative when that is applied to the negative 8x squared, a negative and a negative, when multiplied together, make a positive. Because what you can imagine is, as I'm distributing this negative, is that everything's being multiplied by -1. So -1 times -8 would make positive 8x squared. And we will have a -11. -1 times 11 is -11. In short, the shortcut, when you have a minus sitting outside of parentheses, you are able to just flip the signs, whatever is inside the parentheses. But please note, we must handle this first before we begin combining like terms. Otherwise, we are not going to get the correct answers. Okay? So now that we've distributed our negative, let's identify the like terms and simplify. 2x cubed and negative x cubed. When we combine the 2 and the, remember when we don't have a number there, it acts as a 1. 2 and -1 leaves us just with +1. So we end up with x cubed when combining the coefficients. 5x squared and 8x squared combines to be 13x squared. -3x and -11 do not combine. They do not combine. Why? Because they're not like terms. In fact, -3x has no like terms. Neither does -11. So they just come on down. We are left with our simplified polynomial, x cubed plus 13x squared minus 3x minus 11. I'll underline that in a different color so we don't think that minus 3x and minus 11 combine as like terms. Okay, so the little wrinkle that we have here is if you have a minus sign in between your parentheses, make sure you go ahead and distribute that first. All right, final example. Now, this will be a great test to see if you're really getting this or not. Okay, so really, after I write down the problem, pause the video, try it on your own, and really test yourself. See if you are getting the concepts we're addressing here when we're talking about simplifying polynomials. 30d cubed minus 29d squared minus 3d minus 2d cubed plus d squared. Let's try and simplify it. Pause the video, see if you can figure this one out. Okay, we need to combine our like terms, but we have a minus sitting outside of parentheses. So we need to go ahead and distribute that minus before we ever combine our like terms. Otherwise, we will most likely improperly combine our like terms. Notice nothing changed with my first parentheses, not because nothing ever changes with the first parentheses, but because there's nothing out front, like a minus sign of our first parentheses. I distribute that negative, and that 2d cubed becomes minus 2d cubed. D squared becomes minus d squared, and now I identify my like terms. 30d cubed and minus 2d cubed becomes 28d cubed. Negative 29d squared and negative d squared become negative 30d squared. Again, because we are subtracting a negative from a negative, that total has to go lower. So negative 29 will go down and become negative 30. Again, if you struggle with subtracting negatives, let me know. I can help you out, or double check your work with a calculator. And the only guy is negative 3d. Nothing matches negative 3d, so they just come on down. We are left with 28d cubed minus 30d squared minus 3d. Here's what you must walk away with from this lesson. Number one, we are entering the world of polynomials. Polynomials are algebraic expressions that have two or more terms. Specific types of polynomials are binomials and trinomials. What isn't a polynomial is a monomial, which is when we only have a single term. How do you tell what is and isn't terms? look for the plus and minus signs. If two terms are separated by minus and plus signs, so we can use the minus and plus signs to help identify how many terms there are. Once we figured out how to identify how many terms were present and what the algebraic expression is, a monomial, a binomial, a trinomial, we then moved on to simplifying polynomials. We simplify polynomials by combining like terms. Remember, like terms have the same base and the same exponent. We had to be careful if there was anything outside the parentheses, like a minus sign, and make sure we distributed that through the parentheses first before we combined our like terms. Guys, thanks for watching. Let me know if you have any questions. Have a great day.